Hi, my name is Shannon Blocker, and today I will be sharing diagnostic and management information for pumpkin production problems. I will discuss fertility, insect, and disease issues for commercial pumpkin growers. I will begin by discussing pumpkin fertility. Soil tests are the best tool for predicting pumpkin crop nutrient needs. Tissue sampling is especially helpful when comparing a good area to an area of the field expressing symptoms. The target pH for pumpkins is 6.5. Allowing the pH to decrease below 6.0 can adversely affect crop yield and quality. When lime is needed, apply it at least 3 months, preferably 6 months prior to when the crop will be planted. The nutrients of importance to cucurbits that are most affected by soil pH are phosphorus and manganese in the soil. Phosphorus is most available between 6.0 and 6.5 pH. Manganese availability increases as the soil pH decreases, going from sometimes deficient above 6.5 to being excessive or toxic near pH 5.0. Maintaining the soil pH in the 6.0 to 6.8 range improves the availability of magnesium and calcium. Here are soil test-based fertilizer recommendations for pumpkins and other cucurbits. Following the correct method for tissue sampling allows for applicable results. These are the tissue nutrient sufficiency ranges for pumpkin leaves. Nitrogen deficient plants are yellow and stunted, with the symptoms expressed on the older leaves first. In severe cases, leaves eventually turn brown and die. Fruit may be misshapen and few in number. Excessive nitrogen causes weak vines and excessive growth. The pumpkin plant focuses on vegetative growth and does not produce many flowers, or they are at least delayed. Reduced flower numbers result in lower yields and/or delayed harvest. With phosphorus deficiency, the oldest leaves yellow and the leaves throughout the plant are stunted and smaller. Interveinal leaf spots sometimes occur. Phosphorus deficiency symptoms are most common early in the season due to reduced uptake in cold or cool soils. Potassium deficiency is characterized by a marginal chlorosis with the leaf margins dying, especially at the tip in severe cases. In soils with a high percentage of shrink-swell clay, potassium can be trapped in a soil structure as it dries, making it unavailable for uptake. Dry soils, excessively wet soils, and/or root diseases can all reduce potassium uptake due to their impact on roots. Calcium deficient plants are stunted, having distorted, cupped leaves and characteristic interveinal chlorosis. Symptoms first appear on new growth. Since a large portion of Kansas soils have limestone-based plant material, calcium deficiency is uncommon. If soil and/or foliar nutrient analysis confirm calcium deficiency, the field should be limed based on soil test recommendations. Foliar application of 2 pounds of calcium per acre per application may provide some in-season benefit, but long-term correction needs to come from lime application to the soil. Maintaining adequate soil moisture is helpful in minimizing blossom end rot, associated with an inadequate calcium getting to the blossom end of young developing fruit. Magnesium may also become limiting under acid conditions, especially in sandy soils. Maintaining the soil pH in the 6.0 to 6.8 range improves the availability of magnesium. Foliar application of 2 pounds of magnesium per acre per application may provide some in-season benefit, but long-term correction needs to come from application of lime to the soil. 20 to 50 pounds of magnesium will correct magnesium deficiency, and 1 ton of domolytic lime provides about 200 pounds of magnesium. Therefore, soils with a liming history will almost never be magnesium deficient. This table characterizes pumpkin crop response to fertilization for 4 micronutrients when the soil test level is low. Zinc, copper, and boron are not likely to be a concern for the growth and development of pumpkin. Zinc and copper deficiencies are not common because of past and current use of fungicides containing these elements. Boron deficiency only occurs on the sandiest soils due to excessive leaching. Pumpkins are highly responsive to manganese fertilization when the soil test level is low. Manganese is absorbed as manganese 2+ ions, and uptake is affected by other cations such as calcium and magnesium. Manganese is relatively immobile in the plant, so the symptoms are expressed on the young leaves first. Deficiency of manganese resembles that of magnesium. However, manganese deficiency appears on the upper leaves of the plant. Manganese deficiency consists of interveinal chlorosis. However, the chlorosis is more speckled in appearance compared to magnesium deficiency. High pH soils often induce manganese deficiency by holding manganese in an insoluble form. Avoid overliming and consider sulfur applications to lower pH. Manganese fertilizers can be foliar or soil applied. High levels of manganese can be toxic to plants. Toxicity appears as marginal leaf necrosis. Concentrations of manganese on the order of 500 to 800 parts per million can result in toxicity in many crops. Solubility of manganese in the soil solution is increased by low pH. Excess manganese in the soil solution can reduce uptake of iron by the plant. Iron-deficient plants are yellow and stunted, with the symptoms expressed on the young leaves first. High pH soils often induce iron deficiency by holding iron in an insoluble form. Powdered or pelleted sulfur applications may be used on limited areas to lower pH. A number of chelated iron compounds are available for spray application. Molybdenum deficiency is characterized by a whitish tan interveinal chlorosis accompanied by marginal leaf burn in severe cases. Older leaves are affected first. Plants are usually severely stunted. Use a balanced fertilizer and keep pH between 6.0 to 6.8. Insects are both necessary and can become pests for pumpkins. Pumpkins require insect pollinators since they have separate male and female flowers. Poor pollination is evident in this photo of developing pumpkin fruit. The most common insect pollinators are European honeybees, wild bees, wasps, and flies. In diversified farmscapes with a history of growing cucurbits, squash bees and/or bumblebees have consistently been shown to provide sufficient pollination of pumpkins and squash, regardless of whether honeybees were present. Pumpkin flowers open by daybreak and close by noon. Populations of pollinating insects may be adversely affected by insecticides applied to the flowers or weeds in bloom. Apply insecticides only in the evening hours or wait until bloom is completed before application. Not only can these pests do damage by direct feeding, but cucumber beetles and aphids can spread diseases such as virus and bacterial wilt. Cucumber beetles are small mobile insects with shiny backs, usually yellow-green with black spots or stripes. The top photo shows a spotted cucumber beetle, and the bottom photo is a striped cucumber beetle. When plants are young, they need to be protected from cucumber beetle feeding. Cucumber beetles are the vector of bacterial wilt disease. Cucumber beetles can also direct damage pumpkin rinds. Fall treatment with foliar insecticides to prevent feeding damage may also reduce the incidence of black rot. Squash bugs are a major pest of pumpkins in Kansas. Adult squash bugs can be identified by their large size, about 3/4 of an inch, and overall gray-black to brown appearance. They are the Hemiptera order, also known as a true bug, and go through incomplete metamorphosis. Eggs are easy to see because they are relatively large, 1 to 1.5 millimeters. When laid, they are orange-yellow, turning somewhat metallic bronze several days later. Transparent eggs are those where nymphs are about to hatch or have already hatched. The amount of time between egg deposition and hatching depends on temperature and ranges from 1 to 2 weeks. The first signs of squash bug foliar feeding are small yellow specks at the feeding site, which eventually turn brown. Severe feeding can cause entire leaves to turn brown, wilt, and die. Signs of stem feeding include a rapid wilting of the stem and entire runners. Wilted stems and leaves become dry, crisp, and blackened. Direct feeding on fruits can cause distortions and discolorations and render the fruit unmarketable. Fruits that have been heavily attacked do not keep well and often rot and collapse soon after storage. Sanitation efforts should include removing all debris around garden sites to deprive squash bugs of overwintering sites close to the garden. Immediate removal of plants and fruits after harvest will deprive squash bugs of their food source. This procedure is especially important in autumn because squash bugs continue to feed and develop on pumpkin fruits after the vines have wilted. If squash bugs are deprived of their food supply before building up fat reserves needed to sustain themselves through hibernation, survival will be low and adult populations the following spring will be lower. Use of insecticides for managing squash bug populations requires diligent monitoring of squash bug activities for proper timing and application. Squash bugs are not equally susceptible to insecticide treatments at all developmental stages. Eggs are impervious to insecticides. Insecticides are most effective against the earliest instar nymphs. Effectiveness decreases as the nymphs mature. Adult squash bugs have thickened cuticles that inhibit insecticide penetration. Insecticide application should begin when nymphs emerge from eggs. Because adult squash bugs continue to deposit eggs throughout the growing season, weekly treatments may be required to keep populations in check and enable maximum squash and pumpkin production. It is imperative that insecticides be applied thoroughly. Squash bugs prefer to remain hidden on lower stems and on the underside of leaves. Initially, squash vine borers go undetected because there are no visible symptoms, since they are small in size and they have minimal larval feeding damage. Larvae feed more voraciously as they increase in size. Substantial tunneling results in the destruction of internal vascular transport systems. Plants can wilt, collapse, or die beyond points of feeding. Tunnels become packed with moist, frassy materials. Cultural control involves destruction and deep plowing vines that are infested with squash vine borer. Also, a trap crop of early planted summer squash will attract most of the squash vine borer moths to deposit their eggs on those plants, enabling most later plantings of pumpkin to escape squash vine borers. Remove or destroy earlier vine growth where squash vine borers should be concentrated. For effective insecticidal control of squash vine borer, larvae must be killed upon their emergence from eggs, before they tunnel into the plants. Spray applications must be made when adults first become active and reapplied periodically to ensure sufficient residual effectiveness throughout the period of greatest adult activity. The peak of activities for squash vine borer moth is approximately halfway through their 4 to 6 week flight period. Growers must be vigilant in their efforts to visually detect the beginning and duration of moth activities. Commercially available pheromone lures placed on sticky traps can help monitor squash vine borer activity. Aphids are sucking insects that feed on the sap within the food-conducting tissues of the plant, reducing its vigor and causing distorted growth in severe cases. Aphid feeding is often accompanied by the presence of black powdery mold growth on leaves. This so-called sooty mold, the mold growing on the sticky honeydew excreted by the aphids. Aphid populations can build up to damaging levels in the absence of natural predators, and pesticide resistance is a common problem with this pest. Recommendations for minimizing aphid infestations include crop timing to avoid high population periods, proper planting to ensure uniform stands, and avoiding over-fertilization with nitrogen, delaying use of insecticides until economic thresholds are met to reduce likelihood of inducing pesticide resistance, and ensuring good coverage under the leaves of insecticides when the plants are sprayed. Spider mites are barely visible with the naked eye, but their characteristic damage is easy to recognize. Leaves subjected to mite feeding are described as bronze or silver because of the damage to the green tissue, and a characteristic web is often present on the leaves and young shoots. Populations of mites increase rapidly during hot weather. This chart lists several insecticides and rates their effectiveness on major insect pest species. We'll now discuss diseases. Successful disease management involves good cultural practice such as selection of resistant cultivars, proper site selection, and crop rotation, as well as chemical control of the disease itself and the insects that spread it. There are 4 major causal organisms or groups for pumpkin diseases: fungi, mildews, bacterial, and viruses. Many of the pumpkin fruit rot diseases are caused by fungi. Anthracnose is most severe during relatively warm periods with frequent rainfall and a high relative humidity. Anthracnose will initially be small tan lesions with darker margins. They will expand as they age and damage larger portions of the leaf. They may develop small holes in the leaf. Anthracnose also causes lesions on the fruit. The disease organism survives in infected fields in crop residue, so crop rotation is important. A preventative spray program using a systemic fungicide may be required for effective control. Gummy stem blight is a foliage disease of cucurbits and is usually known as black rot on pumpkins and squash. On pumpkin, the fungus causes the formation of tan to black lesions on the vines. These lesions often are located where the vine forks. A gummy brown fluid leaks from the diseased tissue. Vines affected by the cankers usually wilt and die. The fungus produces numerous black fruiting structures on decaying vines that are readily visible with 10x hand lens. The most conspicuous symptom of black rot is the formation of lesions or spots on the fruit. Initially, these spots are small, 1/4 of an inch in diameter, depressed and straw-colored. Depending on environmental conditions, these lesions may expand rapidly and turn black. Secondary soft rot organisms quickly colonize the decaying tissue, penetrate the rind, and finally result in the collapse and rot of the fruit. Remember to rotate fungicides with different modes of action. Fungicides with the same or similar modes of action are designated with the same group number or letter. Producers can also take mix or use premixes with different fungicidal groups. Phytophthora is a widely distributed organism that often infects plants early in the growing season. Symptoms may be hidden until apparently healthy plants collapse very quickly, particularly as they experience the stress that accompanies fruit loading. Plants often wilt and die without changing color. Proper irrigation scheduling and excellent drainage are imperative. All cucurbits with wet feet are predisposed to Phytophthora. Mildews are some of the most common pumpkin diseases. Powdery mildew is caused by 2 species of fungi. It is much more widespread on cucurbits than downy mildew, especially during dry, hot periods. This disease is characterized by a white or brownish mealy growth found on the upper and lower sides of leaves and young stems. If plants are severely attacked, the leaves and young stems may wither and die. In less severe cases, the plant may be weakened or stunted. Early defoliation resulting from the disease may cause premature ripening or sun scald. Using a preventative fungicide application is the most effective means for suppressing powdery mildew. However, some pumpkin varieties have been released which demonstrate tolerance to this disease. Fungicides used in conjunction with tolerant varieties offer the most complete disease management program for powdery mildew on cucurbits. Here are the powdery mildew fungicides with their rates and pre-harvest intervals. Downy mildew is caused by an airborne fungus that originates in Florida and moves northward during the growing season. During wet, cool weather, however, it can cause considerable damage. This disease produces irregular to angular, yellow to brownish areas on the upper side of diseased leaves. The underside of the leaves may show a pale, grayish-purple mold following damp weather. The mold may vary from white to nearly black in color. The disease spots may enlarge rapidly during warm, moist weather, causing the leaves to wither and die. This damage may resemble frost injury, since the entire vine is killed. The fruit from diseased plants are usually small and of poor quality. Fungicides containing mefenoxam are the most effective for suppressing downy mildew. However, fungal insensitivity to these fungicides has been observed, and switching to chlorothalonil products has been recommended when this problem is observed. We will now discuss bacterial pumpkin diseases. Angular leaf spot is a bacterial disease that attacks gourd and pumpkin leaves, stems, and fruit. The bacterium which causes angular leaf spot overwinters on old plant debris and in seed. Rain splash it from the soil to the stems, leaves, and later to the fruit. Once infection takes place, the organism is spread over the field on the hands of workers or by cucumber beetles. Angular leaf spot is most severe during extended rainy periods when the temperatures are between 70 and 80 degrees Fahrenheit. Spots on the foliage are straw-colored to light brown and angular-shaped. Affected areas are first water-soaked, then gradually dry and split. After the diseased tissue splits open, portions of it tear out, leaving irregular-shaped holes in the leaves. Small, circular spots develop on the fruit. These diseased areas later crack open and turn white. The primary disease prevention tool is to use disease-free seed. A 2-year rotation behind crops other than cucurbits and cultivating the soil when it is dry will decrease the availability of the bacterium to survive to infect upcoming cucurbit crops. During warm, moist periods when disease development is favorable, copper sprays may reduce the spread of the disease. Bacterial wilt is a common and destructive disease of muskmelon and cucumber. It is less common on squash and pumpkin. Symptoms of bacterial wilt may develop any time during the summer, but it is more pronounced in late spring or summer soon after transplants are placed in the field. Diseased plants initially are dark green and wilt slightly during midday. Soon thereafter, the plants go into an irreversible wilt and die. To diagnose bacterial wilt, cut the stem near the soil line and squeeze the cut end between your fingers. Then place the tip of a knife blade on the bead of sap that has extruded from the stem and slowly pull the knife blade away. If a slimy string develops between the blade and the vine, then the plant is probably infected with the bacterium. On healthy plants, the slimy string does not develop. Alternatively, place a small section, 1/4 of an inch thick, of the lower portion of the stem in a shallow dish containing water. After a few minutes, you should see a cloudy, slimy bacterial oozing from the cut end of the vine. The cucumber beetle transmits the bacterium that causes the disease. The beetle survives the winter as an adult in debris at the field edge. In the spring, the adults contaminated with the bacteria migrate to the field and begin to feed on the plants. The bacterium is introduced into the plant through feeding wounds. Once inside, the organism blocks water-conducting tissue, which results in wilting. Virus diseases have become increasingly important as limiting factors in pumpkin production. Several virus diseases, including cucumber, squash, watermelon, and zucchini yellow mosaics, may be present. Disease symptoms vary depending on the particular virus, but generally plants are stunted. Younger leaves may turn yellow or mottled and often are distorted. Older plants develop a distinct mottling on leaves and fruit. Severely affected plants fail to produce fruit. All of the viruses previously mentioned, except squash mosaic, which is vectored by cucumber beetles, are transmitted from plant to plant by aphids. Aphids can transmit the disease in 10 to 15 minutes in some cases, so aphid control is not an effective management tool. Also, certain viruses such as squash mosaic and cucumber mosaic may be seed-borne. None of the viruses persist in the soil for long periods. Stylet oil sprayed on a 2 to 3 day schedule has been shown to delay the spread of the virus, particularly in the fall. Virus diseases are much worse in the late summer and fall because the aphid populations are much higher and virus-carrying host plants are more available, which result in more virus-carrying aphids. Cleaning up field borders can help reduce populations. Yield losses are directly related to the time of infection. The later the infection occurs, the less damage is observed. In this podcast, I discussed fertility considerations and shared pictures of nutrient deficiency symptoms. Pumpkins rely on insect pollinators, but other insects are major pests. Disease prevention and management is important for a successful pumpkin operation. This slide and the next list the references used in this presentation. Photo credits are given here and on the next slide, in addition to where they are used in this presentation. This completes my presentation on troubleshooting pumpkins.